Today we're going to learn how does grounding work. By grounding, we mean connecting an object to the earth by a conducting wire so that all electrical charges on the object flow to the earth. Let's model grounding by using two spheres, a small sphere of radius small r and a large sphere of radius capital R. Let these two radii be related such that capital R is equal to 100 times small r. Now let us give this small sphere a charge of +1 coulombs and the larger sphere has no charge. Later, the two are connected with a metal rod. Now what happens to this +1 coulomb charge when the two spheres are connected? Let the charges after being connected be small q and +q, capital Q. Now let's see this in terms of electric potential. Before being connected, the electric potential on the smaller sphere is given by K times Q over R, where K is the electrostatic constant, the Coulomb constant, and the potential of the larger sphere is given by K times capital Q over capital R. Now remember, small q is equal to +1 coulomb and capital Q is equal to 0 coulomb. Therefore, the potential of smaller sphere has some value while the potential of the larger sphere is 0 volts, which means when the two spheres are connected, there is a potential difference between the two. Therefore, that 1 coulomb charge will redistribute until there is no more potential difference. In other words, the two spheres after being connected become equipotential, which means V1 is equal to V2 is equal to V. So setting these two equations equal, we get K times big Q over big R is equal to K times small q over small r. We can cancel the electrostatic constant from both sides, which gives us capital Q over capital R is equal to small q over small r. Now remember, big R is equal to 100 times small r, so let's substitute that in our equation. Now we have capital Q over 100 times small r is equal to small q over small r. We can cancel r from both sides, which gives us big Q is equal to 100 times small q. In other words, the charge on the larger sphere is 100 times the charge on the smaller sphere. So the charge on this sphere is 100 coulombs, or is 100 times the charge on this sphere. Now going back to grounding, where the radius of the earth was very, very large compared to the radius of the object. Now in this equation, if r was very, very large, this q becomes very, very small, which means if capital R is close to infinity, small r is close to 0. This is what happens when we ground an object that is connected to the earth with a conducting wire. Almost all of the charge flows into the earth, leaving almost no charge on the object. Now there's one question. When lightning strikes, what should be the shape of the tip of the lightning rod? Should it be a small pointed tip or a large spherical tip? To see this, let's consider the two spheres in terms of their charge densities. The charge density on the sphere is given by the charge on a sphere divided by its area. So the charge density on the smaller sphere is small q over 4 pi r squared, and the charge density on the larger sphere is given by big Q over 4 pi big R squared. Now when the two spheres were connected, big Q was equal to 100 times small q, and we had big R is equal to 100 times small r. Squaring both sides, we get big R squared is equal to 10,000 times small r squared. Now substituting these values of big Q and big R squared in our equation for the charge density on the larger sphere, we get charge density on the larger sphere is equal to 100 times small q over 4 pi times 10,000 small r squared. We can cancel two zeros from the numerator and the denominator, which gives us charge density on the larger sphere is equal to q over 4 pi times 100 small r squared. Now compare this to the charge density of the smaller sphere. What do we see? Charge density on the larger sphere is 1/100th of the charge density of the smaller sphere, which means the electric field lines around the larger sphere are much farther apart as compared to the field lines around the smaller sphere. So when lightning strikes, there's a stronger E field near the smaller sphere, which will polarize air sooner than the larger sphere. So when lightning strikes above the two, it would flow to the earth through the smaller sphere. Therefore, I would like to have a lightning rod with a small pointed tip at the top of my building.